Thank you. It's such a pleasure to be here today. I can almost not see you, but I can feel you compared to when we speak in front of the screens for the last 1.5 years. So I would like to first thank the organizers for organizing this live event. It's such a pleasure. I'm really pleased to give this keynote, and I thought I would give you some insight into how ThrustMe became the first company in the world demonstrating a very important key technology for space. What you will see is that it has a technology, it has a potential to revolutionize the space industry or the mobility industry of space. What you will also learn from this talk is that disruptive technologies, developing them is not always easy. It's not always red roses and a joy. It can be also quite lonely sometimes, and this is what I want to share with you today. So just a little bit of background. So we founded ThrustMe together with Dmitry Rafalski in 2017. It's a spin-out from École Polytechnique and the CNRS, from the lab of research of plasma physics, where we had more than a decade of fundamental and applied research behind us in both space propulsion and also plasma sources spin physics that is very important for what we are doing today. We are a very small team of real experts in all that has to do with space propulsion, and this is how we are able to do quite a lot of innovations. And we are, as we have said in the intro, pioneering the use of iodine, and I will show you why this is important. So, space propulsion, we created a company because space propulsion is really very important for the space industry, and it's becoming a crucial asset for the new paradigm where we are now launching an exponential growth of the number of satellites. We have now satellites operating in constellations of 10 to 100 to thousands of satellites, and this changes how we are manufacturing and using and launching these satellites, and it's changing what is a good propulsion solution for these satellites. So in the traditional space, so propulsion, basically you need, most of the engine needs a pressurized or a gaseous propellant at some stage during the operation of the engine. And therefore, the propulsion systems had very often a pressurized gas that is stored under high pressure, and then you have a lot of complex valves to control this high pressure into a low pressure vessel for operations. And this is a problem. This is a problem because it is extremely expensive. And it's expensive because you have to do extreme qualifications. The delivery of these systems is complex, and the handling at the launch pad is complex. So you have to think differently, and therefore you have to think about the propellant used on these systems. So we started looking into alternative propellants a long time ago with many other researchers, and iodine, as you can see here on the photo, is exceptional. What you can see is that it's stored as crystals in solid state, and when you apply a little bit of heat, it sublimates directly to gas. And the iodine gas have the same properties and even better properties than the traditional gas used in plasma-based electric propulsion. So now I use some technological termination. I suggest that you can come to the booth and learn more about the technologies behind it. But anyway, you have the iodine gas that operates exactly the same as a traditional system. But it is stored in solid. And also, iodine is so exceptional because it is abundant. So if we compare it to the traditional propellant, it is 2% the cost of xenon, which is the traditional gas. 2%, what does that mean? Let's assume that we have a constellation of 900 satellites, a magic number. And in these satellites, each satellite would need 30 kilograms of propellant. That means a budget to buy the propellant for $42 million. That's the budget for just the propellant. Not the engines, not the systems. If we replace it by iodine, the budget drops to 1 million euros. That is a saving of 41 million euros just for this one constellation. That's enormous. So alternative propellants exist for others, so it's not only iodine. So we could, for example, use krypton instead, because that's less expensive. So then your budget would drop to 10 million euro instead, so it's quite a good savings. But if we compare iodine with krypton, iodine stores 9 times denser than krypton. So I let you do the calculation and see how much volume you save when you want to launch 900 satellites to space. And then we should not forget also, there is no pressurized loading, which means that at ThrustMe we can now fill up the system pre-filled and ship it by plane to our customers. And they can do all the integration and the launch without any paperwork of pressurized systems. So this is a real revolution in the space industry. It's a real disruptive technology. So now I'm taking a step back. I will not speak too much about the technologies behind, but what I wanted to talk about is what do you do when you come with disruptive ideas? What are you met with? And actually when you have disruptive propositions, and very often when it comes ahead of your time, what you meet is actually a pushback. You meet a pushback because people in general don't want to change. We don't like changes. Industries don't like changes. We get scared of them. It's the same in the space industry. So the first time we spoke about iodine to be used as a propellant was in 2008. What did we hear? We heard iodine, that's interesting, but that will never happen. You will never manage to control the corrosion. You will never manage to convince anybody to use your system. Just forget it. Some years later, we wanted to start looking more into this system, and we wanted to get funding from this. What we heard then was that this technology is not on our roadmap, so we can't support it. So we started pushing again, and then some years later, the other things that we heard was, but NASA, because at that time, NASA had put this technology into their roadmap as a key technology to develop. So what we then heard was, how can you manage to do that if NASA have tried for years and they've not managed? So that is the time when you have to get some grit together and start working on your mental strength. So I would like to share you also some of where I get my mental strength for. This is a photo of Mike Horn, a living explorer. Here, I don't know where he's on the way, but he's on the way to put up his tent. Effectively, it is probably minus 10, minus 30, minus 50 degrees. And some years ago, he was on the way to cross the North Pole together with a friend, his friend from Norway. And to be able to cross the North Pole during winter, they had to change their rhythm. They had to change the day from a 24-hour day to a 30-hour day. They had to do that because if not, they didn't have time to get enough calories into their bodies to move long enough during the day so they could sleep before the ice pushed them back the same length they had walked the same day. So their solution was to change the rhythm. So what I get inspired from is with Mike Horn is that with difficulties you really need to get the discipline to keep going, and behind difficult hide growth. So what you can see here is that at ThrustMe we have developed several systems. The first time we tested the iodine system was in 2019. It was a huge amount of technical issues that we had to solve to get there, and also a lot of political and pragmatic issues that we still need to solve, and we have still lots of technological issues to solve in the long term. But in 2019, we had the first launch, and then this system was a very simple coal gas system, and then 1 year later, so 8 months ago, we had this system tested in space. It's an extremely advanced electric propulsion system that you can, it's really intelligent and true turnkey solution for the clients. So now the question is, how did we manage to test this system in space? We have developed the technology, and now we want to test it in space. We went to China. We went to China because we had tried for I don't know how long time to speak with all the different actors in Europe. And the reply we got was, this is really interesting. Maybe we can apply for money to ESA to get an in-orbit demonstration. Or, this is very interesting, but we would need, 1 million euro to do an in-orbit demonstration for you. And then when we start with the European actors and say, we want a commercial collaboration because we want to give value to you, they say, no, we can't do that before you have been to space. In China, this has been extremely different. In China, they saw the value that we could bring them. And we saw the value they could bring us. China is all about execution, and it's all about being first, and it's all about being before US. So this was our entrance into the Chinese market. We have now 3 systems in orbit together with Space-T. The third system was on their commercial pilot SAR constellation satellite towards their SAR constellation. So this is the team. This is the team that make it all happen. So it's 20 people, and they had the grit to push all this through to make the first in-orbit demonstration of iodine in space in history. Today, they are working night and day to do batch productions and deliveries to clients in both China and the US, and some few in Europe. So with that, I would like to thank you for your attention. The next mission is actually on the launch tomorrow. So we are counting hours now to see being a part of the Falcon 9 rideshare launch is really amazing, and that's happening tomorrow. So thank you very much for your attention.
Thank you, Anne, for that story. We actually are quite good on time, and if you'd like to take a couple of questions for the audience.
I would be happy.
If the technical team can give us perhaps some light in the audience, and I'm looking for Laura or Alberto here, our wingman. Questions? There we go.
Yeah. Actually, it's a good question, because this is one of the biggest challenges with iodine, is that it's corrosive. And this is why boats are rusting on the ocean and so on. So you need to know material science. What we did was to have, before we even started looking at products itself, we started looking at all the different materials that is used in space. And we did a catalog of, now I think we have between 50 and 100 materials that we have tested heavily with iodine. And in that way, we found materials that are compatible, and we found also protections mechanisms to protect materials that is not so compatible with iodine from the direct exposure. So this is it's years of work of understanding how iodine reacts with the different materials. It's combining chemistry, it's combining physics, material science, and this was a huge amount of work to do that.
Any additional questions? Alberto? No? Yeah, there we go. Can we have the gentleman on the left, please? Or you can speak very loudly, sir. That's fine.
What is the best point and what is the worst point of being in France? Well, I came to France in 2006. The idea was to stay for 2 years and then leave. I'm still here. So the good part of France is France. This is the French people. Now, the worst part of France is basically the culture of being scared of risk. Because, and this I think we have to really learn from the Anglo-Saxon and US, is the idea of what is risk and what is failure. And failure, in France we have a very tendency to be afraid of the risk because it's not good to fail. The question is, what is failure? How can we bounce back from saying, oh, I failed, instead of saying, I learned something, I tried something, it didn't work out. But it was not really a failure if you try. A failure to me is when you don't dare to do something. And this is very different, and that is maybe the worst case of being in France, is this risk and this peur. And the French culture is based on peur. And I think we have to work on that.
Any additional questions? We do have time. We go, Alberto, up.
Yeah. Okay, so let me try to confirm what I heard. So your question is about how we entered the Chinese market and how we worked with the Chinese collaborator. So SpaceT is one of the first startups coming out of China. And there is many coming up now. The Chinese market is 40% of the space worldwide market. So it's a very important industry that is growing very quickly. With SpaceT, we have a clear commercial relationship with them. But of course, when you start working with them, you don't have a product to sell because it has not been tested. So you have to find a reason to sell it anyway. And you have to find a reason for them to take it on board. And you can see, if you look, you can see that we have different stages of the relationship with them. In the first case, we tested our small coal gas system that they are not interested in. They did that because they are interested in our high-tech propulsion system in the long term. So we were able to set up a collaboration with them where in the future they will have a commercial deal with us. So this is very different from in-orbit demonstration services, where you pay for a service and off you go and bye-bye. And we didn't want to do that. We didn't want to work with somebody that offers us an in-orbit demonstration solution because it's not a commercial deal in the long term. So you lose a lot of momentum and you lose a lot of time to do that because afterwards you anyway have to set up the collaboration with your client. So you better do that immediately to test your system. So Spacey is our client, and it was our client from day one. And in Orbit, service provider, we would be the client. And you don't want to have this conflict of ideas between who are the real client. Is it me or is it them? And that's why it is important to set up a commercial relationship with the entity very, very early. I don't know if I answered your question.
Thank you, Anne. And perhaps a last question for myself, because this afternoon we have a few startups that will be pitching in front of a jury, and perhaps for them it's the first time they do this. Any word of advice for them before going into their first pitch session?
It's always scary to go on stage. I'm still scared when I go on stage, so it's life.
Wishing them good luck, and actually in the afternoon you're going to discover the startup companies that will be pitching separately, and we'll also be announcing the winner. In the meantime, it's time for us to take a break for lunch. Thank you once again, Anne, and you can find Anne at their ThrustMe stand outside. A round of applause.
Thank you. Bon appétit.
As for me, just a bit of a logistic information for you. We will have about an hour and 10 minutes for the lunch break. You're invited to pick up your lunch at the first floor and then take it outside and enjoy the fresh air together with your food. So looking forward to see you back here with me in about an hour and 10 minutes. We'll let you know. Bon appétit.